Hello everyone, I am Dr. Souvik Patra, faculty in the Department of Civil Engineering, SBIST Govindpur. Welcome you all again to the lectures on Energy Science and Engineering for the third semester, Civil Engineering Department. Today I will start the Module 2, which is basically deals with the energy sources. In the first lecture of Module 2, I will cover a brief overview of the energy systems and what are the sources from which we can harness electrical energy particularly, and which kind of source is beneficial for the environment and which will harmful for the environment will be discussed in this lecture. I will also discuss the transformations of energy from various form to from one form to the another form. I will also discuss the energy efficiency in power plant and also in uses in our electrical appliances in our home, and how we can store the excess energy we produce. These kind of things will also be discussed in this lecture. So let's begin. As in the previous lecture of Module 1, I have provided you a brief overview on the energy system. So energy system basically a network that produce and transform, distribute and consume energy to meet the needs of the society. So the needs of our society is basically the electrical energy. It can be used in your hospital, industry, home, and this is the need of the society that is required for our daily life to sustain in our modern lifestyle. So, and we can harness this electrical energy from this raw material. It may be your solar radiation or it may be your coal, oil. So let's suppose it's a coal. Then we bring this coal to a power plant. We generally call it as a thermal power plant. If it is a solar radiation, then we can use a technology that called solar cell, through which we can harness electricity. And the thermal power plant is the infrastructure. So we transform the raw material to electrical energy through an infrastructure, that is power plant, or maybe a technology that may be your solar cell or wind turbine, this kind of infrastructure. Then this electricity need to be transmitted, and we set up a network of your transmissions line through which we'll get the electricity at our society needs. So all these stages together is known as the energy system, and it is a network of different stages. Now understanding the energy system is requires an interdisciplinary approach, because these stages only civil engineering cannot handle all these things. Because if you consider the first stage, collection of the raw material, here if we want to mine the coal, we require mining engineering, mechanical engineers, also civil engineers. And at the thermal power plant or the nuclear power plant, or you may say hydro power plant, in this stage, we require mechanical, electrical, civil engineering all together. So it is a multidisciplinary approach. Now let's begin. What are the sources of energy available from which we can harness the electrical energy? Particularly, the energy sources can be classified in two categories. One is renewable energy sources, and another one is your non-renewable energy sources. We will classify or define the renewable energy sources, the energy sources which will not diminish or not it will be finished within a lifespan of a human being. That's mean suppose sun, star, wind, river flow. These things are a continuous process, and from the beginning of the earth, these are infinite, going for an infinite time. So the sources which are available for the infinite time, and we can use it again and again. Like if we want to use the wind, it will not be polluted. If it pass through a propeller and rotate the turbine, again the wind can come from again, any direction, and it can rotate the propeller again. So these things are renewable energy sources. It is also known as your infinite source also, because the sources are available for an infinite time. Similarly, we can classify non-renewable energy, which are basically finished or it can diminish within a finite time. That's mean if we consider oil, coal, and natural gas, these resources are limited in our earth. It has a amount. Suppose x liter or x number of tank oil is present, and now at that earth. So after some time, it will be finished. So these things are known as also non-renewable energy, because these resources are finite. Also, another aspect, the difference of renewable and non-renewable energy source is that renewable energy sources are basically environment eco-friendly, or it doesn't causes emissions, it doesn't cause pollution to the environment. But the non-renewable energy sources, which are basically your burning of fossil fuels, is generating lots of amount of harmful gases, and it when it mixes with the air, it become destructive. So if we take the example of your renewable energy sources, these are basically your solar energy. We generally derive the electrical energy from the radiation of the sun, and we capture the radiation by using a photovoltaic cell. So if you may have heard, this is suppose a cell, multiple cell comes together and it form a panel. And when we arrange all this panel together, it create a solar array, and you may have seen this kind of infrastructure in solar farm. Similarly, we can harness wind energy, which is a renewable and clean technology, which basically rotate the turbine. The kinetic energy of the wind flow rotate the turbine, and it will generate electricity like in such a way that if it, this is the direction of the flowing of the wind, and if I install here a propeller and we attach a turbine here, then the wind will rotate the propeller, it will rotate the turbine, and from this turbine we can get the electrical energy. Similarly, we create hydropower from by constructing a dam on a course of the river, and we store the water, and as per our requirement we release the water, and we rotate we use the kinetic movement of the water to rotate the turbine, and we can generate electricity. Similarly, another present technology has been arrived, that is geothermal energy. We basically in that case extract the heat stored beneath the earth surface. Suppose this is your earth surface, and you may have find there is a crack is there, and hot spring you may have seen also. These hot springs are basically generated due to the geothermal heat. So we can use this geothermal heat to heat water and generate steam, and this steam can rotate a turbine, and from this we can get also energy. Similarly, from earlier lives or 100 years back also, we generate electricity or using biomass as source of energy, like burning chulas or ovens like that. So another source of renewable energy is your biomass, which often from the organic materials such as wood, agricultural residues, and animal waste. These are the all examples of renewable energy sources. Similarly, we can also deal some another renewable energy sources like your wave energy, when we use the kinetic action of the wave to harness electricity. Similarly, we can also use the tide, the high tide, and the movement of the water from high tide to low tide. Like suppose this is your estuarian or coastal zone, this is your river. So in at high tide, what will happen? Water will go in that direction, and low tide, in that water will come back to the river. So in that the path of the movement of the water or channel, if we install a turbine, then we can also get electricity. So in that way also you can harness clean energy. And example of non-renewable energy sources are your basically fossil fuels, which are basically hydrocarbons like coal, oil, and natural gases. We burn these fossil fuels and we generate electricity through technological transformations. And another energy source, non-renewable energy source, which is not harmful as fossil fuel, is your nuclear energy, and it generates electricity from fissions, like your by breaking the atom, and also by fusion by fusing together atoms together. So this nuclear energy is also a eco-friendly energy because it generates waste lesser than your fossil fuels. And we can use elements like uranium, plutonium, and also thorium, which is beneficial for your fusion technology. Now, how we can transform the energy, or the how energy transforms in our daily life? So it involves converting energy from one form to another form. We can use it, it may happen biologically, or it may happen your mechanically, or using by some technology. So we can transfer thermal to mechanical energy. It occurs in engines where heat drives mechanical movement. We can also create electrical energy from mechanical energy, and it can be sent in generators where rotating turbines produce electricity. And most of the renewable energy sources, which are basically related to your civil engineering aspect, are mostly your mechanical to electrical energy transformation, sorry, as it is the electricity is harnessed by rotating a turbine. In that case, we transforming mechanical energy to electrical energy. Also, we can transfer chemical to electrical energy, in which is implemented in battery. Also, we can use photovoltaic cell to transform solar energy to electrical energy. Also, in our daily life, you may have seen whenever we eat food through metabolism, we and by transforming it to heat, we transfer energy from chemical to motion. And also the radiation of the sun trapped as a chemical energy in plants through photosynthesis. We burn hydrocarbons and get some motion through thermal to mechanical energy. And we can also use the electrical energy to heat our induction cookers, our uh, fridge, etc. So in that way, the energy basically transformed in such way. Now, when we are transforming energy, and as per the laws of thermodynamics, we know that due to entropy, whenever we are transforming energy from another one form to the another form, in that case there will be some losses. So that's why the efficiency term comes, that how much loss is occurring during a transformation. If the loss is too much higher, then it is not beneficial, or the technology is not too appropriate. So we need to go for more advancement, more research, and all these things. So energy efficiency refers to the ratio of useful energy output to the total energy input. That means if we define efficiency by eta, so if our output energy, it may be joule, it may be your kilowatt hour, whatever, and your input energy. And this ratio is known as your efficiency. Suppose if I provide 100 kilojoule of energy to and transforming it to another form, and we are getting 90, then the efficiency will be your 90%, and 10% has been lost during the process of transformation. So in power plant, combined cycle power plants are achieve efficiencies up to 60%. In that case, we generally use basically Breton and Rankine cycles. In that case, the both the gas turbine and steam turbines both are basically used to harness electricity. And in that approach, we can get the efficiency up to your 60%. And in case of your transportation vehicle like EVs, we have a higher efficiency that is over 80%. We generally lost only due to 20%, which is generally a heat. And in case of internal combustion engine, we generally petroleum engines, which are efficient about 20 to 30%. We can also use this efficiency term when we consider about the conservation of energy, and it is most applicable properly in our home, in our educational institute, in our hospitals, or any kind of industry. So building efficiency is basically implementing of insulation, energy efficient lighting, smart thermostats, which can significantly reduce the energy consumption in a building. That means if we use insulation, that means if we make our walls in such a way that it uh, be cooler, it will be cooler during summer inside, and during winter it will be warmer. This kind of basically HVAC system is there. I will discuss it later. So we can use this kind of technology. We can go for energy efficient appliances, like we can use LED bulb. We can use sensors. Like suppose this is your room, you are living in that room, and here is one sensor is there which will detect the presence or movement of any human being or anything at that room. If we left the room and you forgot to switch turn off your lights and all these things, so the sensor will sense it and it will do the work so that the energy can be saved. So in that way also we can make the our daily uses of energy more efficient. Now that is the part of the that when we are getting energy at our home, and we consider that how will conserve this energy. But at the same time, when we are harnessing the energy at a power plant, suppose at a hydropower plant, harnessing the electrical energy, and I need to transmit already. Suppose I have harnessed your 100 kilowatt hour of your energy, and the requirement is only 90 kilowatt hour. So, 10 kilowatt hour is excess energy or electrical energy we have harnessed. So, if we don't store it, it may be it go waste. So, for this, the storage concept came that whenever we are harnessing electrical energy, what we will do that we will store this energy in some kind of device, and mostly it is known as your battery, where we store the energy. So energy storage is vital for balancing supply and demand, especially in the renewable energy system where generation can be intermittent. So in that case, like suppose if you have a solar cell, at the daytime you have generated electricity, and this electricity has been stored in a battery, and during night time from this battery your home can get this electricity. So storage is very much important. Now the key methods of energy storage include basically your battery storage, and which is generally we use in most of the time lithium ion batteries. Also we can use your sodium sulfur batteries. We have also a solid state battery. So different batteries are available right now, and in this case Tesla is playing a leading role in storage, I mean the technology to advancement in storage devices. Now different kind of storage, energy storage phenomenon can be happen, or we can take this like way, like in case of hydropower storage, we suppose we are generating here x kilowatt of hour of energy, and transmission is suppose we have taken 100 kilowatt of air and transmission is 80 kilowatt hour, and there is 20 kilowatt hour of electricity is excess. We can use this excess electricity, that the water, this is the upstream, this is your downstream, and the water has flowed from upstream to downstream through a penstock, this is known as your penstock, from this zone, and it run through the turbine, generated electricity, and become wasted at the waste as a waste in the downstream. The excess energy, what 20 kilowatt hour is present, excess energy, we can use this energy to pump the water present at the downstream again to the reservoir, so that again we can use this water. So in that way we can also make the hydropower plant more efficient, or the uses of the electricity will be more efficient. Similarly, in case another technology that has been arrived is a compressed air energy storage. In that case, suppose you have a smart grid. Smart grid is basically that one grid from at which the electricity will come from multiple sources, like it may be your wind, it may be your solar, it may be your thermal power plant, nuclear power plant. So in smart grid, what will do that if there is excess energy is present, we will compress air at the underground in a vacuum space, which will be definitely closed environment, and in a high pressure we will compress this air. So that's mean if the air is compressed at a very high pressure, then if it gets a way to go out, so it will go in a very fast speed. So in that case, when require electricity at necessity, at the time of necessity, we can use this high compressed air and make this run to a high velocity, and we can rotate the turbine and we can generate electricity. Another kind of modern, you know, have seen that the hydrogen fuel is a modern fuel. So we can store also hydrogen in such a way that we can take water, and if there's excess energy, we use this excess energy to electrolyte the water. So oxygen and hydrogen will be generated. Oxygen will be released to the air, and hydrogen will be stored, which can be used as a fuel cell later stage. So in such way, we can store the energy. So main technologies are basically your battery, and secondary we can use your hydro pump storage, and this or your compressed air storage, or your hydrogen storage. These are basically depending on your project specific. It may be your hydropower, it may be your hydrogen fuel, it may be your compressed air. But battery is a universal thing. From any kind of any kind of source we can store this. So this is the end of the first lecture of module 2. Let's see you again in the second lecture of module 2. Thank you.